Hi, good day everyone. My name is Igcse and I brought for you today resolution of vectors or vectors resolution. Why we are going to talk about resolution of vectors is because there are so many mistakes our students of nowadays make when it comes to resolving vectors. As you all know, vectors are just quantities that have both magnitude and direction. Being them having the direction make operations with vectors very hard to some extent. It's hard and it's also simple. Where it is hard is because so many students cannot take care of the direction of that vector, where the vector moves and the exact angle to which it moves. With that, we brought a kind of rules and regulation where everyone will make use of to resolve any given 2 or 3 or more than 3 vectors. So first of all, we have cases. There is case number 1. In the case number 1, case 1, when the 2 vectors moves in different direction, there is a way to find their total or effective vectors, vector between them. Is an example. Assuming you have a vector A, and you have another vector B. By mere looking, the vector A is longer and magnified than the vector B. So in this very case, first of all, one should always determine which vector is greater than the other. With my looking, or with the looks of yours here, the vector A is longer than the vector B. That means the vector A is greater than the vector B. So in this case, our effective vector will be toward the greater vector. Since A is the great vector, here is the greater vector, then our resultant vector will be towards the A's direction. That means we are going to have our resultant to be along the A's direction, which is resultant vector R. So how can we determine this type of resolution? Now, always the resultant vector R resultant will always be equals to the vector along the A, being it the greater vector, negative the vector along the B's direction. So in this case, this is how it is resolved. Being this as an object, the force or the vector acted on. Now, if I give this as an example, like you have an object this way and this other way, the vector A has, assuming 20 Newton as a force, and the vector B has 10 Newton as a force acting on this object. Now, automatically, the resultant vector between A and B will be towards the line of A, because A is a greater vector than B. Being it having 20 Newton as a force, compared to the B with 10 Newton, A is greater than the B. So the resultant will always be along A side, which is VR. Now, what we are going to have as our resultant is VR equals to V of A equals to V of A negative V of B. Now V of R will be equals to, my V of A is 20 Newton. So what we have is 20 negative 10. Automatically, we are going to have our V of R to be equals to 20 minus 10, or 20 negative 10 will be just 10 Newton along A. So this is how the case 1 being treated. There is nothing difficult or hard in there. In the first case, it's talking about when 2 vectors acted in different direction. Different direction means opposite direction.